Hello friends, this is Tanvi from Radiance Academy. Today I am going to tell you about the electronic configuration of an atom. So let's begin. What is it? Electronic configuration is a distribution of electrons in an atom. This means that each electron is going to their own home, the shells. Got it? Good. Before starting, the atoms have some rules for you. The atomic number is equal to the number of protons, which is also equal to the number of electrons. The mass number is equal to the sum of the number of protons and the number of neutrons. We'd also studied that each shell has a capacity of some maximum number of electrons it can hold. We had determined this by using the formula 2n square. Thus the K shell can hold 2 electrons, the L shell 8 electrons, M shell 18 electrons, and so on. This is how we will be representing the subatomic particles, electrons and protons with their respective negative and positive charges, and neutrons with a cute pink color but no charge. Let's start with the simplest one, hydrogen. It has an atomic number equal to 1. Remember, the atomic number is equal to the number of protons and also equal to the number of electrons. Thus, hydrogen will have 1 proton and 1 electron. Hydrogen has a mass number also as 1. The mass number is equal to the number of protons plus the number of neutrons. So, how many neutrons will hydrogen have? Here we know that the mass number and the number of protons are both equal to 1. So the number of neutrons will be 0. Isn't this interesting? A bit difficult, but we'll try to understand this with some more elements. Let's see the distribution of electrons in hydrogen. It has 1 proton and 1 electron. This is tiny little hydrogen with 1 electron in the K shell. Here only 1 electron being present, we do not need the next shell. This electron can easily fit in the K shell. Next is carbon, the big brother of hydrogen, with a larger atomic number equal to 6. As we know that the atomic number is equal to the number of protons, which is also equal to the number of electrons. Therefore, carbon has 6 protons and 6 electrons. The mass number of carbon is 12. We found out that carbon has 6 protons. So, to obtain the mass number 12, we need how many neutrons? Guess that. Good. 6 neutrons. So the sum of 6 protons and 6 neutrons becomes 12, which is the mass number. You're doing great. Let's see the electronic configuration now. Here you can see that we have taken 2 shells. Let's see why. In the nucleus, there are 6 protons and 6 neutrons. Now we have 6 electrons. Let's try to distribute them. The first shell, K, has a maximum limit of 2 electrons. So here they come. Out of 6, now 4 electrons are left, which can be accommodated in the L shell, which has a maximum limit of 8 electrons. Here they come. Let's move on. Here is carbon with its 6 electrons, 2 in the K shell and 4 in the L shell. Please welcome our next element, sodium. Sodium has an atomic number equal to 11. The atomic number is equal to the number of protons, which is also equal to the number of electrons. Therefore, sodium has 11 protons and 11 electrons. The mass number of sodium is 23. As we know that sodium has 11 protons, so answer this. How many neutrons do we need to get the mass number 23? Think. 12. Eureka! So, 11 protons and 12 neutrons are equal to 23, the mass number. Now let's see the distribution of 11 electrons. The K shell is now full with 2 electrons. It says bring on the next shell. L comes in, takes 8 electrons onto itself. Now we have distributed 10 electrons. Can we fit the last electron into the L shell? You're right. No, we can't. Atoms always say follow social distancing, no getting into crowded places. We are full. So here comes our 11th electron into the M shell. Oof, we've finally done it. Yes. This is sodium with its 11 electrons. I think it wants to say thank you. Thanks for watching. If you have liked the video, please don't forget to like and subscribe our channel. For more interesting videos, keep watching.